Hello students, we are back to our channel Physics Fun Room. So we are back with the new chapter Center of Mass, Center of Gravity and Applications. First we learn the center of mass. Center of mass. Before that we'll gather some concepts. Let us consider a particle. Why a raw particle? The particle is a point object. It has no dimension. It has no dimension. Now let us consider an object. What is the object? It is the accumulation of particles. It is the accumulation of the particle. Accumulation of the particle. Now there is the interparticle distance. Okay, if we apply external force F external, if the interparticle distance does not change, then that body is called the rigid body. That body is called the rigid body. Now if we consider the motion of the object, there is a motion of the whole particles. There is a motion of the whole particles. Instead of such particles, we consider a point. Consider the motion of that point. What is that point? If the mass of the particle 1 is m1, m2 and there is n numbers of particles, we consider that there is a point whose mass is the same of the whole particles. That point is called the center of mass. Now if a body moving, there is three types of the motion. What are the motions? Number one, pure translational. Motion, pure rotational motion, and number 3 is a combination of translational and rotational motion. Now what is the pure translation motion? If a body coming down from the tip of an inclined plane, its motion is a pure translational motion. If a ball rotating about its axis, then it is called the pure rotational motion. If a ball were rolling down on the inclined plane, that should be the translational motion as well as the rotational motion. So here it is a mixed motion. Now let's move to the another topic. What is the expression of the center of mass? Expression of center of mass of two particle system. Two particle system. How to find it? Draw the right hand Cartesian coordinate system. This is x, y and z. Now take 2 point objects. The masses are m1 and m2. The masses are m1 and m2. Now join them. The position vectors are r1 and the position vector of m2 is r2, and this is the point. This is C, and its position vector should be capital R. Now there is an external force F1 acting on the particle 1 and an external force of F2 acting on the particle 2. Now here, if we have the velocities of the first particle is v1 and the velocity of the second particle is v2, then we can write it that is v1 vector is equals to d r1 by dt and v2 vector is equals to d r2 by dt. Those are the velocities of the two particles. Now F1 is the external force and F2 is the external force on the first particle and the second particle. Now let us consider F of 1, 2. There is an interacting force between two particles. So F of 1, 2 is the internal force on M1 due to M2. That is the force on M1 due to M2, and we will also consider that F of 21. What is F of 21? You can say it easily that the force on M2 due to M1. Now let's move to the next line. If we consider that the rate of change of the linear momentum of the first particle is dp1 vector by dt, that will be equals to the force on the first particle. On the first particle there is a force of F1 plus the internal force F of 1, 2. Okay now? Next we can move that if d dt of p1 is the m1 v1 vector, that is equals to f1 vector plus f of 1, 2 vector. Okay now? So if we consider the second particle, we will get the same result in the version of the second particle. Now we can write d dt of m2 v2 vector, that is equals to f2 vector plus f of 21 vector. It's clear for everybody. Now we are going to add two equations. D dt of m1 v1 vector is equals to f1 vector plus f of 1, 2 vector, and also d dt of m2 v2 vector, that is equals to f2 vector plus f of 2, 1 vector. Now adding it, we have what we have. Remember that is d dt of m1 v1 vector plus d dt of m2 v2 vector, that is equals to f1 vector plus f of 1, 2 vector plus f2 vector plus f of 2, 1 vector. Now common out the d dt, we have m1 v1 vector plus m2 v2 vector. that is equals to f of 1 2 is equals to minus of f of 2 1. Why? It's where it comes from. It comes from the Newton's third law of motion. In the Newton's third law of motion, every action has equal and opposite reaction. So f of 1 2 is equals to minus of f of 2 1. So that will cancel out, and we have f1 vector plus of f2 vector. Now if we consider that the v1 is, now putting v1 is d of r1 by dt. Now move to the next line. We have, move to the next line, d dt of m1, v1 is d of r1 by dt plus m2 into d of r2 by dt, that is equals to f1 vector plus of f2 vector. You can understand it. Take. So now carrying out the d dt, that d2 by dt square into m1 r1 vector plus of m2 r2 vector, that is equals to f1 vector plus of f2 vector. Now what we are going to do it, that is equals to the f vector. Let us take that is the f vector. Now multiplying the m1 plus m2 in the denominator and the numerator, what will have m1 plus m2, we have d2 by dt square of m1 r1 vector plus m2 r2 vector by m1 plus m2, that is equals to the f vector, that is the force, total force due to f1 and f2. Now move to the we can remember that we have considered the r vector. The r vector, we have considered the r vector. Now putting it that place, we have m1 plus m2 into d2r vector by dt, that is equals to f. So the total force equals to mass into acceleration. Now from that we have the r vector is equals to m1 r1 vector plus m2 r2 vector by m1 plus m2. Okay, that is the equation of the center position of the center of mass, equation of the position of the center of mass. From that we can move to the velocity of the center of mass, acceleration of the center of mass, etc. Now before that we take a numerical to better understand that concept. Let us consider two particles. There is a mass of 2 kg and a mass of the 4 kg. They are separated by a distance of the 4 meter. What is the position of the center of mass? What is the position of the center of mass? Now to find the center of mass, we know that r distance is proportional to 1 by m. Okay. Now from that we have r1 by r2, that is equals to m2 by m1. Okay. Now from that if we consider that is r1 and that is r2, we also have the equation r1 plus r2 equals to 4. Now putting m2 and m1, so m1 is 2 and the m2 is 4, so 4 by 2. Now r1 is equals to 2r2. Now putting it in that equation, what the result will come out, 2r2 plus r2 is equals to 4. So r2 equals to 4 by 3 is the position of the center of mass from the 4 kg mass point. Now let's move to the another numerical. This is a right hand Cartesian coordinate system. Okay, the x, y, this is z. Okay, now let us consider 2 points are denoted by 2 position vectors. Here m1 is equals to 1 kg and m2 is equals to 2 kg. We have considered it, we assume it. Okay, now find the position of the center of mass. If r1 vector is given I hat plus j hat plus k hat, and r2 vector is given 2i hat plus j hat plus 2k hat. We consider it. Now we know the expression. We have already find the expression of the position vector of the center of mass. R is equals to m1 r1 vector plus m2 r2 vector by m1 plus m2. Here m1 is 1 and r1 is I hat plus j hat plus k hat plus m2 is 2 and the position vector is 2i hat plus j hat plus 2k hat. Now dividing it 1 plus 2, so we have I hat plus j hat plus k hat plus 2 to the 4 I hat plus 2 j hat 2 to the 4 plus 4 k hat by 3. Now let's move. That is equals to I hat plus 4 I hat is the 5 I hat plus j hat plus 2 j hat is the 3 j hat plus k hat plus 4 k hat is the 5 k hat by 3. That is the position vector of the center of mass of two particles. Now to move another numerical, we'll find out some expressions for the axis x and y and z for the center of mass of the body or the system of particles. Now we have r vector is equals to m1 r1 vector plus m2 r2 vector by m1 plus m2. Now r vector can be written as r x, okay, rx I hat plus ry j hat plus rz k hat. It can be written in that way. Or small r1 vector, that is the position of the first particle, is equals to x1 I hat plus y1 j hat plus z1 k hat, and the r2 vector is equals to x2 I hat plus y2 j hat plus z2 k hat. Now putting it all together in that equation, we have m1 x1 plus m2 x2 by m1 plus m2 I hat plus m1 y1 plus m2 y2 by m1 plus m2 j hat plus m1 z1 plus m2 z2 by m1 plus m2 k hat. So equating this, we have rx is equals to that Ry is equals to that and Rg is equals to that. So we can find the center of mass of the system of particles for the different coordinate systems. So here, now take an example. Let us draw this coordinate system. Okay, there is a particles forming a square. It has a side of this x dash, y dash. It has a side of the 1 centimeter or 1 meter, you can take it. Okay, that is. Now find the center of mass of that system of particles. How to find it? If this is 1, this is origin, so coordinate is 0, 0. Now for the next one, then along the x-axis, O, A, B, C, A point is 1, 0, and that B point is 1, 1, and C point is lying on the y-axis, so it has the coordinate is 0, 1. Okay. Now the center of mass R of x is equals to, if we consider that mass is 1 kg, 1 gram, that is 2 gram, that is 3 gram, and it is the 4 gram, what we will write, that is the 0 into 1 plus, for this 0 into 1, and for this 1 into 2 plus, that is 3 into 1 plus, that is 0 into 4, by total mass. Total mass is 1, 2, 3, 4, 1 plus 2 plus 3 plus 4. We can find the center of mass along the x. Now find the Ry. Ry is equals to, that is 0. Okay, that is 0. Now next 0 into 2, that is also 0. Now 3 into 1, plus, for the 4 gram, that is 4 into 1, by total mass, that is 1 plus 2 plus 3 plus 4. So we can find the coordinates of the center of mass of that kind of system of particles. So we have, now we can write Rx, Ry is the position of the center of mass. So students, that is enough for the day, and we will back with the new numericals and the new concepts and the concept clearing classes later on. And for the day, goodbye, stay tuned, and please share, subscribe and like my channels.